Hey, Dr. Cheryl.
Hello, anybody there?
Hello.
Hello.
Hello, Abby. Hey, Vincent. How are you guys? Give me just a second, and I'm gonna get set up here. Okay.
Okay.
Right. So let's see. Gonna get my computer still waking up. I went to sleep while I was taking a break there. What do we have here? Abby, Ken, Tyler, Vincent, and Leo. How's everybody doing?
I'm okay.
Doing well.
Good. Okay. Good. Excellent. That's good. Let's see. What can I how are we doing on the lab reports?
Pretty well. I hit a snag on one of them.
I
Okay.
finished UV vis and Raman. I just need to do
Okay.
fluorescence.
Okay, cool.
I'm at the beginning, so.
Okay, all right. Well, that's a good place to be. You can hear about the problems and reflect on them. Was
Yeah.
that, let's see here. Was that Tyler? Did you say you had hit a snag?
Yeah. For the fluorescence lab, I've gotten to the joules per mole. I just want to know, what weight are we using? Are we using the formula weight of 479 grams per mole, or are we using the molecular weight of 444.57?
So this is joules per mole of photons.
Oh, okay.
So joules per, yeah. Basically, these are about the photons. So sure. Let's see. Let me get a share going on here, and I'm going to open the lab manual. But basically, you just take the joules per particle, which should be, in the 10 to the minus 23rd range or something. And then, or I'm sorry. Yeah, and then multiply them by Avogadro's number. And that'll give you joules per mole. Does that make sense?
I remember that from physics.
Yes. Physics.
So joules per particle, and then the particle weight that we're using is the weight of a photon? Right?
No, joules per particle. It's like saying, joules per egg, right? And then if you got a dozen eggs, you got joules per dozen eggs. Right? You don't need to know the weight of the egg. You just need to know how many a dozen is. So you multiply by Avogadro's number, and then you're there.
Okay.
It is super easy.
So I just to clarify, I just take my joules and multiply by Avogadro's number, and that's it?
Yep. Exactly right. Exactly
very
right.
Easy. Awesome.
Yes. Super
Thank
easy. You're welcome. You're welcome. Cool. So let's see here. That was in.
So for the chart that he was talking about, we're finding the absorption and emission for each of them. Is that related to when we're calculating the photon energy?
So the absorption has a weight. Each of these has a different wavelength, right? So like the absorption maximum is about 528, and the emission maximum about 548, right? And so if this is 528, this guy's 548, right? Then what we would do is, E is equal to HC over lambda. That's what goes there. Then this is just E times NA, right? I guess it's capital A there, right? And then in electron volts, there's just a conversion between EV and joules, and it doesn't come to mind. So this is like E per molar. And then E in EV is equal to E molar. Oh, wait. I'm not sure if you use E particle or E molar. Probably E particle. It's probably E times the conversion factor. And then reciprocal wavelength is right. Basically, you take 1E7 nanometers per centimeter and divide by lambda. That's how you get the reciprocal wavelength there.
So do we do that for both the absorption and emission? It's the same thing.
Mm-hmm. Mm-hmm.
Okay.
Mm-hmm.
Oh, okay.
Yeah.
Awesome.
Yeah. And there's it's funny because if the total Stokes shift here, the 20 nanometers, it's probably going to be around, I don't know, about 60 millivolts or so, 0.06 volts. That's the sum of these two, the sum of the maxima of these two vibrational manifolds. So these guys are initial states, right? And these are final. And then these guys are initial for the fluorescence process. And these are the final. And this is the vibrational coordinate. Oops. And this is the energy. And this is the absorption. And this is the emission. That's all I was looking for there. Just labeling the stupid diagram. You know. So let's see.
On the Excel that you showed us, it says instead of the sorry, I can't really see the number anymore
Okay.
for the lab manual, but it's a different number for the emission spectrum. Different
Yeah,
thing.
yeah. It's about 20 to 40 nanometers on the red side of that guy.
So do we still use the example you showed, or do we use the one on the Excel?
Oh, you can use this one here. Hey, it doesn't really matter, to be honest. I'm not going to notice. You know, you can use. The idea was you would take it off your graph, you know, but it's really fine if you just use the value from the lab manual.
Okay.
You know, it's everybody who's ever taken Chem 155 has done the same set of calculations. You know, so it's really not. There's really nothing to it there. So let's see. Let's see. What is the? I want to find the conversion factor. So
I found a number. I'm not sure if it's the correct conversion factor. It's 6.242 times 10 to the 18th.
yeah, that's right.
Does that
That's
sound
right.
Yeah. Okay.
That's exactly right. So you use the particle. So like you're going to use this value here. So, and then it's like this, all this E particle here, or photon.
Okay.
And then the conversion is, like you say, 6.242 times 10 to the 18th. Yeah.
For C, are we using 3.0 times 10 to the 9th?
Well, you could, but if you want it in meters per second, it's 10 to the 10th. So like, the C value here, C is 3 times 10 to the 8th meters per second. or you know, so what you it's probably easier to do is use lambda in meters. So if you got 528 nanometers, just say 528 times 10 to the minus 9 meters, and divide that into 3 times 10 to the 8th meters per second, and then multiply by h is 6.626 times 10 to the minus 34 joule seconds. Capital H, little h, darn you.
Oh, Dr. Terrell, I have a question.
Yes.
So I'm looking at the long lab report, and it has a separate section for the figures and tables and stuff, whereas I'm kind of used to still putting them in.
That's like, totally fine. Totally fine.
Okay.
You can put them in line. Put them in line. It's I'm sure it will be better. I think that's a little bit dated. Yeah, if you can just shove them in there, that's absolutely fine.
Okay, cool.
Yep. So, did you get the 3XL parts done?
Yeah.
Excellent. So you are done up to here, basically. Up through 6, you're done, and then you just want to use. I mean, basically, it's a humongous clusterfuck, and I apologize for that.
It's okay.
But the t-tests are basically, they're all going to fail, most likely, you know.
Yeah, my results had higher standard deviations than yours.
Oh yeah. So it's possible that they won't fail because the standard deviation was so huge, right?
Yeah.
That's also possible. But you know, if your answer is going to be 20 plus or minus 15, you know, you could say, oh, I got 35 with 95% confidence. It's like, okay.
Yeah.
You know, it's like, you can say that there's no difference within error, but it's just the error is humongous.
Yeah.
So that's kind of like where we are in some cases. Or if the error is more reasonable, if it's only a couple of milligrams and you get 40 or something, it's supposed to be 20, then you can say, well, this is an enormous error, and it probably has to do with our sample preparation.
Right. Yeah, that's the thing I hate about doing all this stuff online, is because and part of it's my fault for doing it so much later than we did it. But it's just hard to remember, and since we didn't run our own data, the procedure for some of it's still a little weird.
Yeah. Yep.
Like my 162 lab, we're doing anything and everything is just based off of old data, and I hate it.
Yeah, I know. It sucks.
Yeah. Oh, I also had a separate question not related to this class.
Yeah.
I have no idea what my grade is going to be in my 162L lab, and I was wondering if the no credit thing will still count as it'll
right.
Will
it still count towards your degree? I know.
Yeah,
I don't even know the answer to that. Right now, our policy is it has to be graded, you know?
Right.
But I'm going to ask that question today in department meeting. We're finally having a stupid department meeting. And I'm going to ask that question, and I will get back to you all in the form of an announcement.
Yeah, because my minor, I'm unfortunately sitting at a C in one of my other classes that's not chemistry, and that one I know at least, like the Justice Studies Department is counting it. Like they're like, it's
Hmm.
fine. It should count towards your degree. Like it's okay.
Well, if you take the letter, right?
Well, no, the C would, but I also don't want to jack up my GPA.
Uh-huh.
You know?
So you're going to take it credit, no credit then?
Depending on how it ends up with the final, there's only been 2 graded assignments.
Yeah. Oh, Jesus.
That's where I have a C.
Oh, jeez. Two graded assignments and a final. It's like, where are we? Europe, you know?
Is that a class with Bolton?
No, it's the
sounds like it is.
class. I know.
Oh, gotcha.
No, it's the entomology class, which is supposed to be really lab based.
Yeah.
But yeah, like, and then I think we have to like catch bugs and stuff by tomorrow, which I haven't caught any bugs. Because I don't want to catch any bugs.
Oh, come on. You can catch bugs. You don't like them?
No.
Well, you know, I can guarantee you that sentiment is not reciprocated by the bugs.
No, it's not. I'm the only person in that class who hates bugs.
Oh, my dear. Okay. Well, I mean, I think good thoughts for you about catching bugs. You can put gloves on.
Yeah.
You know, get a jar.
I've got some jars. Yeah.
Find some non-objectionable bugs. You know, find some butterflies and, you know, and
yeah.
one thing I strongly recommend against is going into Duncan Hall. And don't go to Duncan Hall, and particularly don't go into the bathroom because it's a fucking cockroach hell. It is horrifying.
Well, I mean, you and I got off the elevator one time, and there was just like a cockroach in the basement right in front of the elevator.
Oh yeah, they're all over the place now. The thing is that in the hallways, they're all dead. They're all just like some of them are half smashed, some of them just turned over and died. Some of them are like, But then if you go into the bathroom, there's like, oh my God, there's like 10 fucking cockroaches running around on the floor. It's like
they're
terrifying. Yes, exactly. Not recommended.
Oh, believe me, I've already had to dissect a cockroach. I don't want to touch them again.
Oh, yucks. Yucks.
Yeah.
Sorry to interrupt.
No, of course, Vincent. What's your question?
For the joules per mole, you said you multiplied the answer you got from calculating joules with Avogadro's concept?
Yeah. Yes, exactly.
Thanks.
Yep. 6 times 10 to the 23rd. Yep. So let me ask you this. No, actually, I'm not going to ask because I don't know the answer. But how is Avogadro's number calculated?
Yeah, you're asking us?
Yeah, and I don't actually know the answer, you know? It's like somehow they had to find the weight of an individual particle, I think. Yeah, it's probably based on the weight of the proton or something like that. And then the weight of like an ideal gas. That would probably be a good way to do it. But it's not super precise. It's sort of a weak link. But it's not really a physics weak link. It's more like a chemistry one because you know, you don't really need to know this arbitrary, you know, dozen type number to great precision.
I can't remember when we did the ICP lab. Did we add the spikes by weight or by volume?
We did volume.
Okay.
And there is a file. Let me get that file for you.
Would the answer come out to a relatively big number?
Which one?
For joules per mole.
Oh yeah, it's gonna be in the like 100 kilojoules or something, like 10 to the 4, 10 to the 5.
All right.
Yeah.
I got a number like that.
Excellent. Yeah. You know, like kilojoules per mole is a typical unit, right? And when you're talking about, oops, oh man, it's plugged in. How could it not be plugged in if it's plugged in? I'm going to reverse both of these. Yeah, you know my okay. I do want to plug it in. Trust me, I do. But how can I plug it in? If you I think I know what's going on here. I plugged it into my phone charger. That's not going to help, is it? There we go. Yay. Let's see. So the question on the table was
how much we added of each.
Yeah, how much we added. Yeah, so that should be here in dilutions.
That's what I'm looking at right now, and like I don't quite know.
Okay. Here they are as masses. Sorry.
Okay, at the very bottom, spike.
Yeah, exactly. Yep.
Sweet.
Yeah, and then you take this milligram. Right. So these are actually the number of milligrams. So this is 1 times 1,003. So anyway.
Yeah.
So this is.
And then
so these are. Go ahead.
No, I was just gonna say. I know you said we could do our calculations like with copper, just to like make our life easier. But in the report, should we include copper, iron, and zinc?
Yeah, that's the idea. Yeah.
But then, when we talk about our results, just talk about the copper results.
Oh no! Talk about all three. Results. I'm sorry, I must have given you the wrong impression at some point. You can do the homework with just one of the three, but for the report, there's not that much that's different, right? If you want to do if you did the homework, right?
Yeah.
Then you can then you can just copy the Excel file, or you can copy the tab.
Right.
And then you just have to make sure that the new, if you're changing element, there's a new spike mass and there's a new expected value. And then I think, and then, there's obviously new calibration data, but there's not that much you need to change. And if you kind of keep it organized, you can just sort of copy and paste stuff over.
Oh yeah, I got different tabs.
Good. Excellent.
Sorry, what was the conversion value again?
For what?
For the electron volts.
Hold on. Let me get over there. Oops. Let's see here. I just Google that again, actually. Say joules to EV. Yeah. 6.242 times 10 to the 18th.
Thank you.
You are welcome. So let's see. Let's see.
Has anyone else been playing Animal Crossing?
No. I don't make money, so no.
Oh, really? You can make money with Animal Crossing?
Oh, no, but
you can, but yeah, you have to pay for it.
You have to pay for the game. I got it. Yeah.
The game is like $60.
Oh my gosh.
Yeah, anything from Nintendo, even if it's old or new, it's gonna be around 60.
Expensive. Yeah.
Howie.
Rocket League was only 20 at least.
Oh, okay. Outside of third parties, like the actual Nintendo titles are always going to be 60.
Yeah.
Wow. Gee,
No, but
Nintendo.
I've been
Mercenary.
working.
Mercenary.
Oh yeah, Dr. Terrell. It's been so annoying. Haven't even been able to do any of my chem stuff for my job.
Oh no. Yeah,
Like I've been working, but not doing that.
Do you guys go into work, or do you work from home, or?
We haven't even done anything for it. He says he wants to start up once my finals are done.
Okay, that's all right. Yeah,
but
I think
the USDA isn't doing anything right now, so we haven't been doing anything.
Oh, got it.
But no, I've just been helping package isopropyl alcohol and still getting paid my normal rate. So.
Okay. All right.
Working in a warehouse.
Working in the warehouse.
Yeah.
Got it.
Sucks.
Well.
It honestly sucks, mainly just because I don't speak Spanish. Everybody else there speaks Spanish, if barely any English, and so like I can't talk to anybody.
Oh no. Can you say, Órale?
Oh my god.
Huevón.
Like, I know very little Spanish, and they all know it by this point, but it's just like, ugh. And people keep thinking I'm older than I am. Somebody asked me if I was married. Somebody else asked me if I had kids.
Oh, that's right. You do look a little older than you are, aren't you? See here.
And I was just like, guys, no.
So this is my host brother. This is me. This is Mitra, my wife. This is my host brother, Mauricio. He's Colombian.
Nice.
And this is his husband, Walter, and Walter is Chilean.
Nice.
And me and Mitra went to see Mauricio and Walter over Christmas, and Mauricio, over the years, his English has gotten pretty good, but we traded off between speaking Spanish and English. And Walter worked for the UN all of his life. I know, it's really amazing. He was in civil aviation for the UN, and they were doing projects all over the globe, like doing, getting countries set up to, be in international standards, and, doing their airports and all this stuff. But yeah, so I got to polish up my Spanish a little bit, and but it's really suffered a lot over the years. Plus, I'm trying to learn Farsi, which Mitra speaks completely unashamedly. She speaks Farsi all the time, and she never teaches me. It's like pulling teeth to get her to teach me a word.
See, my boyfriend speaks more Spanish than I do, and he looks whiter than I do. Which is funny.
Yeah, I mean, Mauricio and Walter, they could pass for white too, pretty much, but they're both, definitely, South American, so.
Yeah, it's always funny. Like, I've shown pictures of him to people, and I'm like, he speaks more Spanish, and they're like, what?
My goodness gracious. Yeah. This was in a little cafe where they have, they show their German roots in Chile, because there's a lot of Germans in Argentina and Chile. And they make Kuchen. Kuchen is, I guess, cake in German.
Okay.
So my brother went to Germany once, and he learned one word. It was Kuchen.
Nice.
Kuchen.
Yeah, one of them tried to teach me the word for mother-in-law the other day. I don't know why.
Oh, suegra.
Yeah. That's
Suegra.
what he said. I was saying that I get along with my boyfriend's mom, and he was like, "Ah, suegra," and I was
like, exactly. Suegro and suegra.
But I've been getting a lot of bomb Mexican food, so.
Excellent.
Yeah, and some pan dulce.
Got it. Excellent. So where's your Hispanic roots from? Your mom, your dad, both?
My dad.
Uh-huh.
My dad is Mexican.
Mm-hmm.
But we don't he doesn't really speak a lot of Spanish, and we're not close to his family at all. So I don't really have.
That's too bad.
Yeah.
Because Hispanic families can be really awesome.
Yeah, I see them working together here.
Yeah, my ex-wife is Hispanic, and I miss her family so much. But I'm kind of, they're nice to me still, but I don't hang out with them.
Yeah.
Too many questions. But they had great parties and lots of parties and.
Yeah, I believe that.
Yeah.
From what I hear from other people and my friends that are Hispanic.
Yeah.
But no, it's cool though. I've gotten really I now have a newfound respect for the packaging process of shipping packages.
Oh, cool.
Why it takes so long. I get it.
It is just astounding. Wherever you go, whatever you do, jobs are so specialized and they're so technical, and I think one of the things about it is that it's hard to even understand how much we depend on everybody else for everything.
Yep.
We're just used to turning on a faucet and getting clean water. If that didn't happen, everyone would effing die.
Yeah.
It would take 2 days and we would all be dead. There'd be a few riots at Costco trying to get the last remaining bottled water, and then we'd all die. And then same with garbage, same with power, same with everything. We just are all so amazingly interdependent. And it's slightly scary sometimes, but it also tells you how many people just play by the rules. So many people are just such good people.
That's true. All the people I work with are awesome.
Yeah. Just really cool people. Work hard, play by the rules, it's just amazing.
Yeah. Well, the part of the packaging process that I'm the best at is sealing them once the bottles are in. Because we sell bottles of isopropyl alcohol. That's what we've been doing. And you have a machine that I never knew that you can use to cut the tape that constantly just wets it for you, so that way it's actually sticky.
Mm-hmm.
And it's interesting to do that, and then you got to stack them on pallets and make sure they don't fall over, and that's the part I've gotten good at, is stacking them so they don't fall. I have my own really obnoxious stacking pattern.
I love it.
Yeah.
Oh,
that I'm trying to teach other people to do, but since I don't speak Spanish, it's hard.
That's right. Hazlo como yo, huevón.
Yeah. Oh, I should show you. I know that this is office hours and stuff, and if people have questions, please feel free to interrupt me. But
yeah, please.
Okay, on that note, then, really fast.
Yes. No.
While you have the fluorescence open, can we? I know you've gone over it 2 or 3 times, but can we revisit the Stokes shift?
Absolutely, we can. So Let me grab one other thing here, which is the Jablonski diagram. I'm going to get that right here. Okay. I'm just going to grab the Jablonski diagram here. There we go. So I'm going to try to. All right. Can you see the Jablonski diagram?
Yeah.
On one side and the XL on the other side?
Yeah.
Okay, beautiful. So ask your question.
So I understand that, the Stokes shift is due to loss of energy.
Yes.
But so in the lab report, you're asking to kind of explain it. What are you looking for?
Oh, okay. So it's really easy. Basically, the absorption process it's the electronic energy plus vibrational energy, right?
Right.
And the emission process is the electronic energy minus vibrational energy. So the Stokes shift is the plus and the minus, right? It's the plus electronic plus vibrational minus electronic minus vibrational. So it's twice, the total Stokes shift is twice the average vibrational energy loss. Or you can say it's the electronic energy level plus the ground and excited state vibrational energy losses.
Okay. Thank you.
You are welcome. It's really not that complicated. It's just, but it's. I'm glad you asked because it's going to trip a lot of folks up.
Yeah, I'm sorry. So.
No, by all means, ask away.
So, is this talking about explaining why the absorption and emission wavelengths are different?
Exactly right. Yeah, yep. Absorption is electronic plus vibrational, and emission is electronic minus vibrational. You can see that in the, let's say that this arrow right here is the average absorption energy. That corresponds to 528 nanometers, right? Let's say that this guy here is the average in the emission. That's 552, right? Well, if you take out the electronic part, then it's these two levels plus these two levels is the difference in those energies. So it's a little bit of ground state and a little bit of excited state vibrational energy levels. It's a difference in length of the arrows.
Wait, so absorption is what? Minus what? And
absorption is electronic plus vibrational energy. And emission is vibrational, or is electronic minus vibrational energy.
Okay, and because and the arrows indicate
the length of the arrow indicates the energy of the transition. So let me make this larger so you can see.
I can't remember, for the vitamin tablet lab, did we like drop the vitamin tablet, like measure it on its own first in like a beaker, or did we measure the whole solution?
We never measured the vitamin tablet mass.
Okay, because like I have here like my method blank, my spikes, and everything with initial and final masses. I'm just like unsure of what they're of. Because I said that I put the entire sample into a tiered beaker and I rinsed with DI water to collect all of the sample possible.
Mm-hmm.
And I diluted it to 100 mLs.
Right. So that probably you diluted to 100 grams.
Yeah.
And so you're probably gonna have to take the final minus the initial weight there.
But
And
is the
go ahead.
But the sample is of like the whole solution with the vitamin tablet, right?
Right, exactly. Yep, includes everything.
Okay, that's just what I needed to know.
Yeah.
So why are they similar?
What I was gonna show.
Vincent, why don't you go?
Why are they what?
No, sorry. Go ahead.
Mine's chemistry related. It's fine.
Vincent's question, I think, was why do they look like mirror images?
Why are they the same? But then like there's like more arrows on emission than absorbing.
It's sort of an accident that there's more arrows.
Oh, okay. So it's just
that's not supposed to be there really. I should add an arrow.
So for absorption, it goes from low energy to high energy, and then vice versa for
emission. Okay. Yeah. There's really nothing more than this level of understanding that we're looking for. There's no calculations or anything to do.
And the reason why they're different at different wavelengths is because one is taking in vibrational energy, and one is
exactly
releasing vibrational energy. Okay.
Exactly right. Exactly right.
Gotcha.
Exactly right. Yes. Yep. Exactly.
No, I was just gonna show Dr. Cheryl a painting I did. Like that's all.
Oh, cool.
I
gotta see how I can share your screen here. See here. Oh. Okay.
See if I can itself. There we go.
Oh my God, that's amazing, Abby.
Well, it was one of those kits that you like take home.
Oh, nice.
Places they're selling take-home kits.
Oh, nice.
And so I did that this weekend.
Super nice. I wish we could show everybody.
No, you did. It says that you're showing my thing with everyone.
Oh, cool.
But also, if they go to the gallery, they can see. It's not that big of a deal. But yeah, I was excited.
Nice. That's cool. Huh. Now I can't get back the thing that said thumbnail, video, whatever. Okay. Evidently you're on.
Well, I mean, I can see your screen still.
Okay, good. Excellent.
What? I was just going to turn off my video. That's all.
Okay, cool. Thanks. Okay, are we back to normal, everybody?
Yeah, I can still see Excel and.
Excellent. Good. Okay. All righty. So, David, how are you doing, buddy?
Pretty good.
I'm great. Thanks for asking.
Good. Excellent.
I had a question on the Raman lab.
Yes, sir.
So it says we need to do the Stokes wavelength calculation and then the two analysis. I'm not really
yes.
sure how to do
Oh, good question. These are actually kind of tricky. So let me see if I can find this puppy dog. Oh, there we go. So basically, these are good. Yeah. Yeah, these are good. These are good foundational equations to use, right? So, in your question, is it about the questions on the lab report, or is it about the calculation? Like, is it about these questions, these 10 points of questions here?
Oh, sorry, I was going off of the what you had on Canvas.
Oh, okay. Alrighty. The video.
No, you have a grading rubric on Canvas.
Oh, got it. Okay, let me check that puppy dog out here. There's just too many darn places where all this stuff shows up. So
Oh yeah.
the grading rubric should also. Oh, you know what? It should be here. Oh well. Oh, I see. It's going to be 11, 3, 9, 5, and 10. It's going to be 1, 11, 3, 9, 5, and 10. Well, that's going to be 50 points, I think. Or 40 points, I guess. So, rather than me, does the rubric look like it lines up with these 1, 11, 3, 9, 5, and 10?
1, 11.
3, 9, 5, and 10. Or the last 10 might be broken up into 3 different questions.
Yeah,
It's going to be 4, 3, and 3. Yeah.
It looks similar. It says one's the Raman spectra plots, one's the identification of even peaks. One's the percent composition calculation.
Right. Yeah, that's all what I have here in the lab manual. So I think they probably should line up.
Okay. Yeah, I just had trouble on the Stokes wavelength calculation.
Got it. Okay. This is question number 1 here, right?
Okay.
And it's designed to mess you up. So
thanks a lot, Daryl.
Yeah, I know. It's like one of those things I couldn't resist. Like, oh, let's show these guys how stupid we all are. So anyway, basically, there is, if you go into energy, it's pretty simple. That V Raman equals yeah, so basically it's these probably we can just use this equation here. Let me grab this puppy dog. We can come down here. And I'll just pop this in here and then try to make it larger so it's not microscopic. Okay, so the Raman frequency, if you're talking about frequencies here, is equal to the laser frequency minus the frequency that you observe. So it's basically, there's 2 peaks on the spectrum, one at the laser frequency, one at the observed frequency. And the difference between those is the vibrational frequency, right? And that's also the Raman frequency, So V Raman equals V vibe here, right?
Mm-hmm.
Now, if what I did in this was I mixed nanometers and wave numbers. So start out with 785 nanometers. And what you need to do is, actually, I should also say laser. The laser comes out at the Rayleigh wavelength, right? So basically what you need to do is convert 785 into wave numbers, right? And to do that, you use 10 to the 7th divided by 785. So how can I do that? I got to get a calculator here. And that's 12,738. Oops. There we go. So that's, this is the new bar laser. Right? Now, V vibrational will equal 3,000 wave numbers, right? And therefore, I think I'm asking where it will be observed. So V observed will equal V laser minus V vibe is going to be 12,378 minus 3,000 will equal what's that, 9378. Right, and then so lambda equal 1E7 over 9378, which will equal
Wouldn't you multiply them to get lambda? Are you going for nanometers?
So it's this. It's the equation here is that wave numbers is equal to 1E7 over nanometers, right? And therefore, nanometers equals 1E7 over wave numbers. That make sense?
Yeah, I wasn't thinking.
Yeah, no, it's fine. So the laser frequency is here, the vibrational frequency or the observed frequency will be the difference. And that comes out to be 1,027 nanometers. It's 785 plus, a couple, maybe 250 nanometers. David? Wood?
Oh, yeah. Sorry. Yeah. Thank you.
No problem. No problem.
Now, do we have to do number 2? Question 2?
I like that.
Because that uses FTIR.
Oh, that's right. That's mean of me, huh? Yes, we have to do it. And this is, it's actually really, it's kind of an idiosyncratic question, right? And with very limited exceptions, you can never use water as a solvent in FTIR because water is such a strong infrared absorber. It kind of wipes out almost the entire mid-infrared. Now, but Raman and infrared intensities are complementary. So a strong absorber in infrared will be a weak scatterer in Raman, and vice versa. So you can use water as a solvent to do Raman spectroscopy. So you can get vibrational information from molecules dissolved in water, which is very unusual, and it's not that well appreciated. So, blah, blah. The point is, well, the answer is water. And the reason is that water is a very weak Raman scatterer.
Okay, perfect.
Excellent. Cool.
Yeah. So. And then are these lab reports due today?
No, they are due on Monday.
Okay. Perfect. Because on Canvas they say they're due today, so it's kind of.
I know.
Weird.
Actually, I didn't know that. I forgot. But the thing is that if you finish them today, it'll be so nice because there won't be a ton of other shit for you to do as finals are approaching.
Don't be like me. Get your shit.
Don't be like Abby.
I'm trying to finish up fluorescence today.
Good. Yay. I'm going to work away today and I'll grade everything I get today, probably. I don't become obsessed. I'm actually obsessed with a machine shop job.
Is it for the research lab?
Yes, it's for the dip coder. I've been tricking all the stupid little instrumentation out, and so when we get back, we'll have a better tube furnace. We'll have a better dip coder.
Nice. Yeah, because you worked on the spin coder. The spin coder.
I know. The spin coder is standalone, and now the dip coder is going to be standalone too.
Nice.
Yes, and it'll have limit switches and all the other good stuff.
I've just been painting and knitting.
Good. Painting and knitting is good.
Not when you don't do homework, though.
Oh, yeah, that's true. Do homework.
I just can't focus, man. My depression has been so bad.
I know, honey.
It's that baby.
I know. It's like, there's some, I remember this story I heard about a writer. He's a famous writer, but he lived in the 18th century or the 19th century. And he had a butler. and he had the butler lock him to his desk naked so that he would write. So he would be chained to his desk naked and all day. So he would have no choice but to write. He couldn't even lie down, you know?
Yeah.
Sometimes it's like when you've got like serious like mental roadblocks, you just need to get through it, get through the pain. You need something to force you through the pain, you know?
Yeah.
Because it's like you just can't do it voluntarily. You know?
Yeah, that's why I'm going over to my boyfriend's house later so that way I can study.
No, so you can have intense pain and then therefore you're going to study?
Well, because he'll make me study.
Oh,
So.
good boyfriend. Oh my gosh. All
He's
right.
going to be working, so I'm going to have to be sitting there like having to work. Because if I don't, he'll know.
That's right. That will keep you honest. I wish you good luck with that relationship.
Thank you.
Because it's hard, you know, for me anyway, because I'm such a lazy bastard.
Same.
When my wife is working, I resent her immediately because I just want to screw around.
Same.
So somehow we got to get over this.
Yeah.
Dr. Terrell?
Vincent. Yes, sir.
So calculating the photon energy corresponding to the peak of the absorption emission, that's what we did with the table, right?
Yes, exactly.
Okay, so that's for now.
Yes,
okay, that's it.
That's
okay.
all done. Yeah, that's all done. Yeah. Yep. Okay, kids. Unless there's any more questions, I think I'm going to let you all go. Okay, questions.
I'm heading out.
Okay, bye, Abby.
I'm leaving as well.
Yeah.
Okie dokie.
I just have a question for the midterm.
Yes.
So so you said part one's gonna be everything from the first midterm?
Yes.
And then part two is going to be everything after the midterm, right?
Right, exactly, yes.
Will it it's gonna be in the same format, like there's some multiple choice and then some short answer?
Yes, short answer, multiple choice, yes.
All right.
Yep, exactly right.
All right.
Okie dokie.
That's all. Thank you, Dr. Terrell.
Okay, thanks, Vincent.
Professor?
Yes.
So I had a question on the UV Viz lab.
Yes, sir.
Finding the solutions for the elimination method.
Oh, that's the hardest stupid one, I know.
Okay, yeah. I'm glad I'm not the only one then.
No. It's the hardest part, yeah. There we go. Let me bring this guy up. So, how to do it. Okay. All right. Okay. So what I can sort of write in here. So, oh wait. So let's see. Here we go. Okay. All right. So yeah, this is this process here. Okay. And you need 3 wavelengths. Let me pull up that file. M101 final. Geez. Let's see what this one looks like. This is all raw. This is raw data.
I can take mine if that helps.
Oh, absolutely. Yeah, send it along. Email it to me at roger.terrell@sjsu, and I will open it right away.
Okay.
Perfect.
Let me grab that. Okay, I sent it.
Yeah. Okay.
Hopefully it's the right one.
There we go. Oh, that's from Mitra. Okay. So, did you send it through Canvas or did you send it to my email, to my Gmail?
I sent it to your email, the SJSU one.
Okay. Alrighty. Just hasn't come through.
Yes. And then, well, since we're waiting for that, I had a question about the final.
Mm-hmm.
Is there a way you can show us what?
Yeah, like
what
give you examples or like example questions and stuff.
That and what chapters we've kind of gone over.
Oh, absolutely, absolutely, absolutely. Yeah, yep. I will give everybody a very public disclosure of everything that we've covered that will be on the final. You know, what will be up to the midterm, what will be on the final. And it,
okay.
Yeah, so I promise I will do that. I'll do that. I actually have to do that today and tomorrow so it can be ready for Thursday morning. Okay, let's see. Ah, there we go.
Perfect.
Let's see. Download you. Beautiful, beautiful. Okie dokie. So, let's see. Okay, got it. So, okay, alrighty. So the only one you haven't done is ethyl acetate in the mixture, right?
Yeah. Yeah, it looks like it's just that one.
Okay, got it. So, so basically, we have to come now to 232, right? And then what we can do is we can, we have, this is the absorbance there, right? So what we're going to have is 0.9 2275 equals epsilon EA, right?
Yeah.
That's going to be 229.8 times EA, right? I'll just use the EA there, right? Because that's what we're going to be solving for. That's going to be plus epsilon toluene, which is going to be 225.7 times C toluene, which we now know 0.00027 plus epsilon for acetone, which is 8.704 times concentration of acetone, which is 1.0%, right? Oops, sorry. So this is the equation that we have at this. So this is all taken at 232 nanometers. So this is all. What? Oh, geez, that's so weird. I don't even get it. Quote at 32 nanometers. There we go. So if you go to 232, then you've got the 3 extinction coefficients up here, right? And you've got you've got 2 of the 3 concentrations. So you just need that last concentration value there. So I will just send this back to you, and you can just solve this guy for EA, right? You're going to take this. Oops.
Okay. So yeah, you just solve for EA, and then that's the
right. Basically, yeah. Basically, yeah. Just got to solve it for EA. This guy right here, you know.
Okay.
So I'll just send this guy back. Yeah, you're basically done with this guy now, so that's good.
Yeah, I'll probably submit this today.
Excellent. Excelente San Clemente.
I think I'm done with all 3 now. So
Good. Okay. It's going to have the same name, so
okay.
You might want to close it before you open this guy and then save it to a new name or something.
Okay. Okay. Thank you, Professor. That was all I had questions with.
Cool. Thanks so much. Oh, also, I got your email. And about 180. Yeah, 180 is basically just between prof and a student. So, and you can take up to 3 units of 180.
Yeah.
During your 3 semesters, 3 units can count towards your degree.
Yes.
And so, you just talk to a prof and he'll set you up,
Okay. So okay.
Yeah.
I was kind of confused on how I should sign up because I've heard people tell me I should do it, and then I just didn't really know how.
Yeah, absolutely. Absolutely. Yeah. Yeah, I mean, it's like a little bit awkward right now because nobody's in the lab, but it does. Yeah. It is a very can be a good experience on a lot of levels. You have some lab mates who you get a little bit closer to, and you guys can help each other. And then also, you get a little bit closer to at least one faculty member. They can write letters of recommendation for you and stuff. And
Okay.
Yeah, stuff like that. Excellent.
Thank you.
Cool. All righty. Talk to you soon, David.
Thank you. Bye, Professor.
Bye.